Hey guys, in section 2.2, we're going to build on what we learned in section 2.1 and expand now to a system of three variables. An example of a system with three variables might be something like this, where we have an x, y, and z. So something like this is a system of three equations with three variables, and we could solve it similarly to the way that we did in 2.1. You could use the elimination method, and the solution still has a graphical representation. Just now, we can't graph it on a two-dimensional coordinate system. So this a coordinate system with three variables. It's three-dimensional. And so now we would have a plane instead of just a straight line for the graph. But instead of solving with the elimination method, which gets kind of complicated sometimes, I will admit, I did include an example using the elimination method in the slides. I left that in there so that you could see how that works, but we are going to solve them using a matrix. So here's an example of a matrix that you have in your homework. A matrix is a rectangular array of numbers, and they're enclosed in a bracket. Each of the numbers is an element of the matrix. And so we use this to solve a system of equations, just focusing on the coefficients of the variables and leaving out all of the letters. So this matrix has four rows, so the rows going horizontal. So each of these is a row. So we've got four rows. And the vertical are columns. So we've got 1, 2, 3, 4, 5 columns. So we would describe this matrix as a 4 by 5, 4 rows, and 5 columns. And the location of each element in the matrix described the row and the column where it's found. So the locations of the elements are written here in this notation, which looks just like an ordered pair or an interval. So we use this notation for quite a few things. So it's important to pay attention to the context. But here, these numbers are just represented. The first one is the row, and the second one is the column. So the element 1, 1 would be in the first row and the first column. Another way to indicate that is to use a notation with a subscript. So we would have a lowercase a, and then the subscript would have the row and the column. So in this case, 1, 1. And the number that is in that location on this matrix, the first row, first column, is 20. So the element 1, 1 is 20. So 2 means the second row, the second column. So I would go here to the second row, look down the second column, and that element there is 12. The element 3, 4 would be in the third row, fourth column. So third row there, fourth column is there. Where they intersect is the negative 18. So this element is negative 18. So this is how we identify the elements using this notation with the parentheses. The first number is the row, second number is the column. The second part of this problem gives you an element on the matrix. So they give you a certain number, and you're going to figure out how you would describe the location of that number. So here, negative 18 shows up several times in this matrix. So we need to identify all three of those locations. So that first one at the top is in the first row. So the first number in that location is 1, and it's in the second column, so the second number would be 2. So the location of this negative 18 is 1, 2. This next one here is in the 1, 2, 3 third row, also in the second column, so its location is 3, 2. This negative 18 is also in the third row, but this one is in the fourth column, so its location is 3, 4. Part C uses the other notation, but remember that these numbers are still just the row and column, with row coming first and column being second. So A3, 5, we need to look in the third row and the fifth column. So here's the third row, here's the fifth column. The number that's in both of those is 2. So A3, 5 is 2. A2, 4 is in the second row, the fourth column. So there's the second row, there's the fourth column. The element that's in both of those is negative 12. So next, let's see how we would translate a system of equations into a matrix. This system of equations has three variables. It is three equations. So the coefficient matrix we'll write first, and we need it to be a 3 by 3. So we need 3 rows and 3 columns. And we're just going to put in the coefficients of x, y, and z in each equation. So the coefficient, remember, is the number multiplied on the variable. So coefficient in this first term is the 2. Remember, if you don't see one there, that's a 1. This would be a negative 1 as the coefficient. So we're just plugging those numbers into the top row, the coefficients from the first equation. So we've got 2, a 1, and a negative 1. The second row, the coefficients are 3, 5, and 2. And in the third row, the third equation, the coefficients are 1, negative 2, and 1. So all of these coefficients in the first row are coefficients on the x's. In the first column, they are coefficients on the x's. In the second column, they're coefficients of y. And in the third column, they are coefficients of z. So that's the coefficient matrix. We also can write a matrix that includes these numbers on the right side of the equal sign. And this one's called an augmented matrix. So it would still have all of the same elements that we had in the first. We're just going to include the right side of the equations. And generally we use a vertical bar to separate them. And so we would put everything on the right side of the equations over here, 5, the 11, the negative 1. Okay. So they just got this vertical bar separating the coefficients of the variables with the other side of the equation. So this augmented matrix gives us all of the information from the system of equations, but kind of in a simpler way. So let's see if we could go backwards. If we could take an augmented matrix and write the system of equations that corresponds to it. So that's what we're asked to do in this problem here. They want us to use x, y, and z for the variables. So we're going to keep in mind here that all of these numbers in the first column are coefficients on the x. Second column, they're coefficients on the y. Third column, those are the coefficients on the z. And then all of the numbers on the right side of the bar are on the opposite side of the equation. So these numbers are just the coefficients of these variables. Entering your answers in WebAssign, you won't be able to write your equations vertically like you would on paper. So you'll just write each equation and separate them with a comma. So I'll write the final answer the way that you have to put it in. So our first row, translated into an equation with the variables, would be a 1x plus 3y minus 1z equals 9. Okay, so I'm just not writing the multiplication by 1. But I'm using those coefficients there to make sure I got the right sign. Second row, coefficient on the x is 4, so I've got 4x, 1y, and 4z. That needs to be equal to 0. And the third row, negative 3x plus 4y plus z equals 7. So in your answer box, you would put your first equation, the whole thing, and then just put a comma, and then write the second equation. This is how you've got to enter your answer in that answer box there. So next, let's start to see how we could solve the system using these matrices. So in this next question, let's take a look at some operations and the notation and see how that works. So we are given a matrix, and we're also given some operations there. So this says that we're taking the opposite or multiplying by negative 1, row 3, and then adding it to row 1. And then that's going to become the new row 1. So we're replacing the result in row 1. So let's see what that looks like. First, let's find this here. So we're going to take row 3, multiply the whole row by negative 1. So it's going to become negative 5, negative 2, positive 3, and then negative 1 on the other side of the bar. Next, it says we need to add that to row 1. So row 1 is 4, 1, 2, and 7. So I'm going to add these two together. Add in each element. I get negative 1, -1, 5, and 6. So this is going to become my new row. So first row is going to be -1, -1, 5, and 6. That's what I got from negative row 3 plus row 1. And then that's all it asked me to do. So I'm not changing row 2 or row 3. I'm going to leave them exactly as they were. So 4, 2, 1, 4. And then row 3, 5, 2, -3, 1. As you're solving these, to get to the solution, the goal is to get ones along your diagonal. So diagonal is here. And to get each one of those numbers to be 1 and all of the other numbers, not including this here, but all of the other numbers in the main part of your matrix, you want to be 0. So you want this to be a 0, this to be a 0, this to be 0, this to be 0. That's equivalent to solving each equation for the variable. So here's an example just to show you what I mean, what a solution would look like. So once you get the ones along the diagonal, then translating this back to equations with the variables, this first one would just say that x, because we had no y's, no z's, is equal to 5. The second one would say y is equal to -2. The third one would say z is equal to 8. So once you've got the ones on the diagonal and zeros for all the other elements, then the right side tells you the solution. You can get to this point by using the same operations we did in the elimination method. So you can multiply a row by a number, you can add or subtract rows, and you can interchange rows, switch their position. I'll include videos both on how to solve this by hand and how to put it in your calculator. But anything 3 by 3 or bigger, my recommendation is to use the calculator because they can get kind of complicated. There's lots of options for steps that you can take. There's also a lot to keep track of. So there's lots of places that you could make a mistake. So when you have the option, I would solve these in the calculator. First, let me show you how you would set the matrix. So just making sure that we can translate equations to matrices. So before you can ask your calculator to reduce this, to solve this, you would have to create a matrix. So the augmented matrix here, even though the variables are a little different than what we had before, the process is still exactly the same. We're still just using the coefficients and putting them in the matrix. So the top row, I'm using the coefficients from the first equation. So I've got a 1 for the x1, 1 for x1, I have 1 for x2, 5 for x3. I'm going to put my bar there, and 18 on the other side. The second equation, I've got 4, nothing for x3, so I'm putting a 0 in my matrix, and then 12. The third equation, coefficient on x1 is 4. There is no x2, so that coefficient is 0. And then -1 for x3. So I would use this matrix to solve this system of equations. Next, we want to make sure that we can set up a system from a word problem. So here we've got this problem, and they've already told us the variables to use. They tell us what those variables represent. So we just have to set up the system of equations. So the price of a medium shirt is going to be our x. Price of a large will be y. Extra large will be z. So those are the prices that x is representing. What we're calculating here is a total cost. So to get the cost, we got to multiply the number that we're ordering by the price to make sure that I'm putting things in the right place. I've already got the $389.99 in the system. So that top equation is representing the t-shirts that Alpha Beta is ordering. So I got to multiply 3 by the x, medium's x, large is y, extra large is z. So I'm multiplying 3 times x, 8 times y, 13 times z, adding them all together, and it's got to equal $389.99. All right, so next up, Beta Gamma, they're ordering 16 mediums. So I'm going to multiply 16 times X, 9 large, and it doesn't say anything about extra large. So we're going to use 0 for extra large. So 16 for mediums, 16 for X, 9 for the larges, nothing for the extra larges, and their total is 322.43. Now the next group, they've got 6 mediums, 11 larges, 14 extra larges. Total is 457.26. So this is the system of equations that we would use to find the price of each shirt, because the price is what we don't know, X, Y, or Z. So she could use this system to figure out how much does a large cost, how much does a medium cost, how much does an extra large shirt cost. Right, so that should get you through 2.2. Please let me know if you have any questions.